All right. So we're just reviewing dilations today. We're going to do a lot of problems of review. So as we go through today's lesson, I need to see participation from everybody. So I'm going to be calling on people. I want y'all to answer me when I call on you. I also want to see questions. So if you don't know how I got a number or you're not sure, anything at all, ask me questions. So let's get started. All right. Can I hear from Rios? Can you start us off, please, and read? Rios. See, this is where I'm saying if I call on you, you got to answer me. Jalen.
Line segment AB prime whose endpoints are 4, -2 and 16, 14 is the image of line AB after dilation of 1/2 centered at the origin. What is the length of line AB?
Awesome. Thank you. Okay. Keyword, centered at the origin. When you have a dilation that is centered at the origin, it's actually super easy because when your dilation is centered at the origin, that just means that x comma y becomes kx and ky. And what does k represent?
Isn't that like the scale factors? Oh, I already said it.
No, you both said it at the same time. Good. K is the scale factor. But that only works if it's centered at the origin. So always read it carefully and see where the center of dilation is. If it's at the origin, you're good to go. Okay, then it's saying that, okay, line segment AB prime, has endpoints at 4, -2 and 16, 14. And there was a dilation of 1/2. So the scale factor was 1/2. Okay, so a couple of different ways to do this. It's asking us what is the length of AB. So let's hear some strategies. What is one way that I can figure this out? And yes, Tyrone, it always tells you the center of dilation. Good, distance formula, good. So we can go ahead and I'm just gonna erase this. Did everybody write this down? I just wanna make sure, we're not really gonna use this rule, but I wanna make sure we know it. So when it's centered at the origin, you can use that rule. Take another couple seconds. I wanna make sure everybody wrote it down. Okay, I'm gonna go ahead and erase it. So we can use the distance formula, right? So let's go ahead and find the distance of A prime, B prime. Here are my 2 points. And let's just quick review what the distance formula is. So actually, let me just write it out over here. Can anyone quickly go ahead and let me know what is the distance formula? Tyrone, go ahead.
And it starts with x2.
X2 minus x1 squared plus y2 minus y1.
Yeah. Oops.
Okay.
Good, you got it. Okay.
Thank you, Jalen.
So now let's go ahead and use. Good sir. Let's go ahead and use the distance formula for AB prime. So x2 minus x1, that's going to be 16 minus 4 squared. And then 14 minus -2 squared. What's 16 minus 4?
12.
12. What is 14 minus -2?
16.
Good. What's 12 squared? What's 16 squared?
144.
Mm-hmm. And
256.
good, you got it. Okay, add those together. What do we got?
400 Maganda.
And what is the square root of 400?
20.
20. Is that my answer?
I'm confused.
Reread every time when you solve a problem, reread the question just to check.
L, so it's supposed to be divided by 1/2.
Because what did we just find?
The big one.
The
Is
big
it?
one. We found AB prime. But we need to know AB. And what's the relationship between AB and AB prime? It was divided by 1/2, right?
That's
So
simple.
1/2 of AB is AB prime. So if AB prime is 20, what's the original?
5 plus 5.
Nope. Emily's got it. It's 40. You guys went the wrong way. Was it the dilation factor was 1/2, right? So it shrunk, it got smaller. It got smaller. It was 40, it got cut in half, became 20. See, that was tricky. They tried to trick you and they did. They got you. Everyone except Emily got tricked. So you got to read these things very, very carefully. That really matters. So does anyone have any questions? I'm just spitting truths, Perla. Y'all got tricked. Okay.
Mm-hmm.
So no questions? Going once? Going twice? All right, next one. Here we go. Let me see if Rios is here. Rios, can you hear me? Can you read this one, please? I'm gonna keep trying. Oh, you do hear me. Can you read it? Okay, he doesn't want to read out loud. I'm gonna respect that, but I do want you to answer me privately when I call on you, okay? Daniel. Daniel, can you read for us, please?
Need to, there's something wrong with mouse. Okay. Yes, I can. Carolina drew X, Y, 12 units long on a coordinate plane. Her dilated line segment is parallel to XY, which measures, wait, no, it's X1 and Y1,
Mm-hmm.
12 units long on a coordinate plane. Her dilated line segment is parallel to XY, which measures 15 units long. What was the scale factor of dilation for the line segment Carolina drew?
Awesome. All right, so just quick review of scale factor. So if xy is 15 and xy prime is 12, how do I figure out my dilation factor? Okay, I'm seeing it in the chat. So K, the dilation factor, is it image over pre-image or pre-image over image? So am I going to do 12 over 15 or 15 over 12? Good, 12 over 15. Can I simplify that? There it is, 4/5. Divide top and bottom by 3. We get 4/5. So just wanted to really just quickly review it. You always do, so the scale factor. If you want to think of it this way, it's always image over pre-image. If that might be hard to remember or might confuse you, another quick way to remember it is new over old. Okay, so your new over your old. And just another thing to make sure you know, because this can be a very easy question on the test, to make sure you get it right. Any questions on that? Prime is the image, yes. So pre-image and then image. Cool. Any other questions? All right. Next up, let's hear from, this one's a little bit long, so I'm going to pick on someone who likes to read. Tyrone, do you mind reading this one? Go ahead.
After a composition of transformations, the coordinate A, which is 4, 2, B, which is 4, 6, and C, which is 2, 6, becomes A, B, and C prime. A is -2, -1. B is -1, -3, and C, which is -1, -3 as well. As shown on the set of axes below, which sequence of transformations map triangle ABC onto triangle ABC prime?
Awesome, thank you. Now I just realized there was a typo. So let me just fix that. B prime is at -2, -3. Okay. All right. So yeah, so now let's just try and see, okay, what was the series of transformations? And good question, Perla. The reason that there's a double prime is exactly because of that, yes, because it had 2 transformations. So think about it, after the first round, it's ABC prime. After the second round, it's ABC double prime. Okay, so let's go ahead and take a look. I want you guys to just read the options and let's do a poll for this one. I just want to see where you guys are at right now. So take a little bit, take a moment, read through them carefully and see if you can figure it out. Okay, I see 3 answers in the chat. See 4 answers in the chat or in the poll. Can we get 6 answers in the poll? I'm waiting on 2 more people. Okay, Tyrone is thinking.
I think I got it wrong.
Okay, I got 6. Tyrone, did you answer yet? No? Okay, just waiting on you, okay? Okay, 10, 9, 8. Okay, you answered. All right, here we go. Here's what we got. We got 100% correct. Nice job, you guys. You're all correct.
I thought I got it wrong, but okay.
No, you're totally correct. So first thing is we know that it's a scale factor of 1/2, right? Because it gets smaller. It does not get bigger, it gets smaller. So A and B are definitely out. And then definitely 180, because we always remember 180 ends up completely on the opposite side. Okay, so answer choice C. Any questions on this one? No? Now, in this case, it was pretty simple. It was not the easiest thing in the world, but it was probably a little more simple because the answer choices are kind of obvious if it's right or wrong. So let's say you have 4 answer choices that are maybe 2 of them are really similar to each other. Like let's say you had a dilation of 1/2 followed by a this is one that always trips people up, by a reflection over y equals -x. Because those 2 situations look pretty similar to each other. So if that was the case, what could you do to check for sure? Perla says, do the math. Yeah, that's exactly right. So if you're in a scenario where you're not sure, this is where memorizing those rules would be very, very helpful. Because, okay, if you have a dilation of 1/2, then you know k is 1/2. So that would be 2, 1. And then at this stage, you can figure out whether it was a rotation versus a reflection. Because if you know that the final answer is -2, -1, then like Perla said it in the chat, it's -x, -y, so that we know that that's a 100-degree rotation. If you memorize those rules, you're setting yourself up for success. If you kind of forgot those rules because it's been a long time, I would highly, highly recommend you just spend a little bit of time this weekend remembering them, looking over them, rememorizing them one more time, because it could really save you on a test, on a question like that. So any questions on this? Okay. All right. Similar one, very similar one, same idea. Let's go ahead and do a poll. Yes, Tara. Did I give homework? No, I haven't, because I mostly just want you guys to study this weekend. What is the rule for y, -x? That would be a 90-degree rotation. What is it always? What is it like counterclockwise? Okay, I've got 6 answers in the chat. I would love to get one more, but I know Rios had to go step away for a moment. This one made your brain blow up. Oh my gosh. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here we go. It was between A and B, but B was more popular. Now let's check if B is correct. Okay, so I brought it up because I knew it was coming, right? Reflections and rotations by 180 they look very similar. They look very similar, and sometimes it's hard to tell them apart. So we all agree it's not C and it's not D. Okay, because it is growing, exactly, so it becomes bigger. So the next thing is to try and figure out between a 180 clockwise rotation versus a reflection over xy, x equals y equals x. There's a mathematical way to do it. You can always check using math, but I also want to make sure that we understand visually what the difference is. So the line y equals x, can somebody draw that? Can anyone draw that for me using an annotation tool? What does that look like? The reflection over y equals x. Go ahead, Perla. Go ahead and draw it. Perfect. So that's y equals x. That's the reflection line. I want everybody to tilt their head over. Tilt your head so that you can see it and picture if FGH was just a little bigger, right? Because we want it to be the right size. But if FGH was just a little bigger, would those two triangles match up if you closed it like a book? Would they match up? Yeah. Yes, they would. So when you're trying to figure out, is it a reflection or is it a rotation? Visually, remember that over the line of reflection, they have to match up. Now, let me show you the difference over here. Sorry, let me delete the line. In this case, if I drew the line, this would be y equals negative x. I'll make it thick as well. Tilt your head that way. Would those two triangles line up if you shut it like a book? No, right? So this was not a reflection. This is a rotation. Now, in a rotation, here's the other thing. In a rotation, look at what happens. A was on top. Actually the other way. A was pointing downward. Where does A become? Goes up to the top. And the reason is because it does a 180 degree. What happens when you turn 180? You end up facing the other way, right? So you always want to think about that relationship as well. So in this case, F started on top. Does F end up at the bottom? No, right? And if it was a rotation, if this was a rotation this way, F should have ended up on the bottom. It would have looked something like this if it had been a rotation. That's what a rotation looks like. But it's not. It's not a rotation, it's a reflection. So just like Perla drew before, if I draw the line, y equals x, then you can kind of tell that if you shut it like a book, those two triangles will line up with each other. So B was correct. Now, and like I said before, you can always check mathematically, right? So G, where does G start on the graph? Where is G? Good. Hold on, no. G, just G. Where's G? There it is, 3 comma negative 3. Okay, we know there's a dilation of 2. So what is G prime? Where's G prime? After the dilation. Good, 6 comma negative 6. Then look on the graph, and where does G double prime end up? It ends up at negative 6 comma 6. So that's where, if you follow the rules, what's happening is x comma y becomes y comma x. And if you had memorized your rules, you would know that that is a reflection over y equals x. So see why those rules are really important to memorize, because if you were stuck on this question, if you weren't sure which one it was visually, you can always check mathematically. Questions on this one? We're blazing through. Make sure though, this is your chance. So if you have any questions, right now is the time. If I have time, can I go over the rules? Yes, but I don't know if I will have time. So I can. Just remind me at the end, okay? All right. Next one. I know Perla wanted to read. Do you want to read, Perla?
Okay, I'll read since I'm, oh my God, my mic is not, oh, there it is.
There we go.
Since I'm very much wanted here. In the diagram below, line segment CD is the image of line segment AB after a dilation of scale factor K with sensor E. What ratio is equal to the scale factor K of the dilation?
Awesome. Okay. So this is where, again, kind of reviewing what the scale factor would be. So take a look at the options. We'll do a poll. Here we go. The question was the one that's there. Which ratio is equal to the scale factor of K? All right, I have 3 answers so far. Can I get 6 answers? I've got 4 answers, okay. Can I get 2 more? If you haven't answered yet, let me know in the chat so I can identify who needs a little help on this one. Okay, there, I've got 5 answers. And there's my 6 answers. Okay, here we go. Let's check it out. Most popular answer was A. B and C were a couple people chose those as well. So let's take a look. We're looking for the scale factor. We already went over this. What is the scale factor? What do you always, what over what? Image over pre-image. It's going to be image over pre-image. But another way to do it, which is what's going on here, another way to do it is from this, I'm going to see COD, center of dilation, from the center of dilation to the image, and then from the center of dilation to the pre-image. You can do that as well. So in this case, the image over the pre-image would be BA over DC, but there's no answer choice like that, is there? So they're not using this situation, they're doing the other one, where you go from the center of dilation to the image, and then from the center of dilation to the pre-image. So which one is putting it in the correct order? So center of dilation is E, so E to A would be center of dilation to the image, right? Because which one's my image? Let's actually clarify that. CD is the image, okay. So E to C, that's the center of dilation to the image. And then E to A would be center of dilation to the pre-image. So EC over EA. Okay, so there you go. So there's two ways to calculate the center of dilation. Either you just calculate the image, calculate the pre-image, you're done. Or you can also go from the center to the image, and then from the center to the pre-image. It works both ways. Okay, so any questions on this one? Okay, cool. All right, one more. Oops, one more similar. Let's see who's gonna read this one. Janelle's, can you read for us?
On the graph below, point A 3, 4 and BC with coordinates B 4, 3 and C 2, 1 are graphed. What are the coordinates of B prime and C prime after BC undergoes a dilation centered at point A with a scale factor of 2?
Awesome. All right. So remember what I said. A couple of slides ago, we wrote this down. When the center of dilation, when the COD is the origin, what can you do? There, Perla got it. When the center of dilation is the origin, you can just take your coordinate point, multiply it by the, kx, multiply it by the scale factor. But is that the case here? No, right? In this case, the center of dilation is A. So we can't really do this, unfortunately. It's not going to be that easy. Okay? But there are some different strategies that we can implement. So first of all, we know that the scale factor is 2. We know that the scale factor is 2. So remember what I said before, the scale factor also represents the distance from the center of dilation. So think about the center of dilation. Remember that the center of dilation connects all the dots. So when you extend the center of dilation, that's not where it goes. Hold on. Let me fix that. when you kind of draw a line coming out of the center of dilation, you can basically figure out where all the dilations are going to be, because each of the dilations is going to be somewhere along that line. It has to be. Okay, so now with that in mind, go ahead and take a look at the answer choices, and let's start picking and choosing which one might be correct. Okay, so Perla is saying B. Let's take a look at B. So B is 6, 1 and 0, -1. So that would put me at 6, 1, 2, 3, 4, 5, 6, 1 right here. And 0, -1 over here. Does that work? No, why not? Right. What does it has to be located on the same green lines. So that's not going to work. Okay, keep trying. Okay, Tyrone and Emily say A. Let's check it out. 5, 2, 1, 2, 3, 4, 5, 2. It's a little off, but there you go. And then 1, -2. 1, -2 right here. Ooh, that looks a little bit better, doesn't it? Seems to be on the line. Seems to be, it's parallel. Okay, that looks pretty good to me. Now, what can you do to check? How can I check to see if this is correct? What math could I do? Remember, Perla, I can't do that. Can't do it because the center of dilation is not the origin. How can I mathematically confirm what I see? There we go. Okay, so Janelle's is saying we can use the distance formula. Good, because we know that the scale factor is supposed to be 2, right? Scale factor should be 2. So that means that A prime or B prime C prime should be twice as long as BC. So you can quickly do a little distance formula for BC, do a little distance formula for B prime C prime, and just verify if we do in fact get the right answers. Okay, so can I get the following students? So Tyrone, Daniel, Janelle's, and Perla. So those of you who are in school, go ahead and find the length of BC. And then those of you who are at home, find the length of B prime C prime. square root of 13. School group, do you agree with your classmate Perla? Janelle's got something different. Okay, so confer. Talk amongst yourselves. See if you can figure out why. How about my home group? Jalen, Emily, Rios, Samaj, what do we got? All right, I'm seeing some answers in the chat. I'm seeing some different answers in the chat for those who sent it to me privately. So let me go ahead and let's do both of them. Let's do everybody. We're gonna go ahead and do the top one and the bottom one. So for the top one, here are my points: 4, 3 and 2, 1. So in my equation, I'm gonna write 2 minus 4 squared and 1 minus 3 squared, which gives me -2 squared plus -2 squared. So I got 4 plus 4. So I got the square root of 8. Square root of 8. Questions from anybody at school? No? Okay. Now for those of you who are at home, we're using these numbers, 5, 2 and -1, -2, or 1, -2. So that's going to be 1 minus 5 squared and -2 minus 2 squared. So that's -4 squared plus -4 squared. So that's 16 plus 16, or the square root of 32. Questions on either of those? Okay. Now, do we have the correct situation? Is the square root of 32 twice the square root of 8? How can I rewrite the square root of 32? 32 is 2 times 8? Thirty-two is what times 8? 4 times 8. And what's the square root of 4? Is 2. So this is 2 times the square root of 8. So we do have the right situation. We do have a scale factor of 2. And there you go. Questions on this one? Make sure you understand. If you're not sure where a number came from, if you got something different than me and you want to check why, now's your chance. Yeah, it wasn't too bad. Wasn't too bad. Okay. Question before I continue. I just want to go over something that we didn't really do too much when we were together. So I just want to go through it now. So this might be a little bit newer. If a line is dilated with a center of dilation that is located on the line itself, the resulting image will be the same line. I'm going to read that one more time. If a line is dilated with the center of dilation located on the line, the resulting image will be the same line. And let me explain why that is. So first of all, go ahead and write this down because that's going to be important. It does come up on the test, so I just want to make sure we understand. Let's say I have a line and I have a center of dilation. Call it point A. If the center of dilation is somewhere outside of the line, remember what I said with this, what happens is that the center of dilation is like the connecting point. So if I have this connecting point, then anytime I dilate it, it's going to end up somewhere along this line. So if I dilate the line that I started with, let's call this L. If I dilate it, I'm going to get a brand new, oop, that's not quite right. It'll be somewhere like here. I'm going to get a brand new line. Now, what's the relationship between these two lines? What's the relationship between line L and line, let's call this K? So it's a dilation. That is true, it is a dilation. But what's true about line L and line K to one another? There it is, Janelle, is good. They're parallel. These are parallel lines. Because remember, dilations cause a parallel line. All dilations, when you have one, you end up with parallel lines. So if I look back at this problem, these were parallel. If I look back at this problem, these were also parallel. So you always end up with parallel lines. But what happens if, so let me erase. What happens if the point of dilation, the center of dilation, is on the line? So here's my line, line L. Here's my center of dilation. If the center of dilation is located on the line itself, and if I pick 2 points and I connect them to the center of dilation, it's just going to keep getting, it's going to be the same line, just getting bigger and bigger. You end up with the same exact line. So I just want to make sure we get this, just get it in our heads. If the center of dilation is on the line, you're just going to end up with the same line but bigger, basically. But it's not going to cause parallel lines because we just end up on the same place, in the same place. Does anyone have any questions on that? It's kind of a weird thing, but I just want to make sure that we understand why this works. So make sure even if you don't totally get it, at least make sure you write down the rule. Okay? So with that in mind, let's take a look at this example below. Who haven't I heard in a while? Let me hear from Jalen. Can you read, please? Yeah, we can't hear you.
I forgot to take off my headphones. If the line is dilated with the center of dilation located on the line, but the resulting edge will be the same line.
I meant the example.
Oh my god. Oh my. Okay. So suppose you dilate the line represented by the equation y equals 5x minus 10 by the scale factor of 3. Which of the following center of dilation will result on the same line? I'm sorry for being so fast.
Okay. Which of the following centers of dilation would result in the same line? So remember what I just said. If the point is on the line, it would end up on the same line. So what we need to figure out is which of these points is located on y equals 5x minus 10. Now, Perla says it's not A. How do you know? Oh, so you did exactly what I was just going to say. We're going to plug each of these in and see if it ends up working out. So if you plug in 0, we end up with 0 equals -10. Does 0 equal -10? Nope. So this point is not on that line. It doesn't satisfy the equation, so it doesn't work out. So it's not located on that line. So it's basically what we're just going to keep doing. Plug each of those in and try and see which one works out. So now I'm going to plug in 35 for y, -5 for x. What's 5 times -5? Good. -25 minus 10. Does 35 equal -35? Nope. So it's not that one either. Keep going.
It's definitely C.
Is it definitely C? Let's find out. -5 equals 5 minus 10. 5 minus 10 is -5. So there you go. So with this type of problem, I already know there's going to be like 2 of these on the test. With this type of problem, you're just trying to figure out if the point is on the line or not. And if it is on the line, then you know that the dilation will give you the same line. How do we feel about this? You feel okay? Okay. I think I have one more. Yes. So let's test your knowledge. Go ahead and take a look, try it on your own. Go ahead and test it out. I'll read it for you. The line representing the equation x plus y equals 3 is dilated by a scale factor of 2.5 with the center of dilation 3, 0. Which statement is true? Okay, I have 3 answers in. I have not yet, Perla. I haven't gotten all my results yet. 4 answers in, 5 answers in.
Dr. Lopez.
All right, 5, 4, 3, 2, and 1. Okay, I'm not going to share the answers yet. I'm not going to share the answers yet. Okay, the line representing the equation x plus y equals 3 is dilated by a scale factor of 2.5 with the center of dilation at 3, 0. Is 3 comma 0 on the line? How do you know?
I first made it into slope-intercept form,
Mhm.
and then I just plugged in the coordinate point.
Do you have to make it into slope-intercept form?
I don't think so.
No, you don't. You don't. You just did extra work. You can just plug it right in. So x is 3, y is 0, 3 plus 0 is 3. Does 3 equal 3? Yeah. So 0, 3 comma 0 is on the line. So if 3 comma 0 is on the line and I dilate it, I'm going to end up with the same line. It's not perpendicular. It's not parallel. It's the same exact line. And the reason I didn't share the results is because these were the results and they're a little disappointing. Because we just went over it. We literally we just went over it. And I asked if there were any questions, and then there were no questions. So to me that doesn't make any sense. So I just need to make sure that we're doing things correctly. Do I have any questions? No questions? Jalen, can you read the definition again one more time, which you read it before even though you weren't supposed to?
That was by accident, but okay. If a line is dilated with the center of dilation located on the line, the resulting image will be the same line.
Don't make a silly mistake on this question. Okay. Yes, this is a good one. Okay. Can I get who can read this one? I've heard from pretty much everybody, so at this point, would anyone like to volunteer? Yeah, actually, you're right. I want to hear from Daniel. Daniel, can you please read this one for us?
Yeah, there's something wrong with my screen.
Oh, you can't see it?
Like I could see it, but it's shrinked and it's at the top of the in the middle like how it's supposed to be.
Huh. Okay. Give yourself a moment. See if you can figure it out. So if you can't read it, that's okay. Can I get another volunteer?
Oh, never mind.
Okay, cool.
I must have clicked something. Okay, the line segment is dilated by a scale factor of 2, centered at a point not on the line segment. Which statement regarding the relationship between the given line segment and its image is true?
Perfect. So this time the point is not on the line segment. So go ahead and take a look at your answers and answer your poll. All right, I've got 4 answers. So far, everybody has gotten it correct. Just waiting on 3 more. Okay, 5 answers in. So far, so good. I'm going to give you all 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Happy New Year's. Good job, guys. Everybody got it correct. Well done. So yes, they will be parallel. And since the scale factor is 2, the new line segment will be twice the length of the old one. Questions on this one? All right, we got 2 more questions. I think we'll finish a little early. Let's see. Perla, can you read this one, please?
Okay. The equation of a line is 6x minus 3y equals 5. A dilation at the origin with a scale factor of 6 is applied to this line. Part A, what is the slope of the line after the dilation? Part B, what is the value of the y-intercept of the line after the dilation?
Okay, so this one's a little challenging. It's kind of bringing in a lot of algebra skills. So let's go ahead and talk about it. So we know that the dilation is centered at the origin. So what we need to figure out is whether the origin is on the line or not on the line. Okay, so what do I do? Okay, so we can start by making it into slope-intercept form. Okay.
And you plug everything in
Yeah.
after you solve for x and y.
Okay. So if I go ahead and I'm going to turn it into slope-intercept form, what do I do to both sides?
So to get x, wait, are you trying to get y or x?
We're trying to get y by itself.
Okay. Then you would have to subtract 6x, then add, wait, no, divide -3.
Perfect. Perfect. Okay. Well, when I divide by -3, I end up with y equals, what's -6 divided by -3?
2.
2. And then 5 divided by -3?
5/3.
Yeah, we're just going to leave it as 5/3. 5/3. Okay. What's the
But don't we
slope?
need x to actually find out the y-intercept?
No, because we actually have the y-intercept right in front of us. Since this is in slope-intercept form, what's the slope?
Oh. I thought you had to actually find the number for x and then plug that in. And then you got a
No,
number for y. I didn't think it had to be an equation.
no, it's actually right in front of us. Everything is where we need it to be. So I know that the slope is 2, and I know that the y-intercept is -5/3. Okay, well, what would be the slope of the line after the dilation? The new line.
I'm hungry.
The old line, the slope is 2.
Give me food.
And the y-intercept is -5/3. My new line has a scale factor of 6. What would be the slope of the new line? So Janelle's is saying it's 12, Perla is saying it's the same. Why would it be the same slope, Perla? Because they are parallel. Remember what we just said. The line segments have to end up being parallel. And if they're parallel, that just means that they have the same slope. So the slope is the same. Slope is 2. Now, part B. What is the y-intercept of my new line? Multiply by 12? By 6. Good. That number we can multiply by 6 because where is the scale factor? What is the center of dilation? The center of dilation is the origin, so we can apply the rule. X comma y is kx times ky. And since we know that the scale factor is 6, well, all I need to do is I need to multiply my y-intercept times 6. So what do I get?
Mhm.
Good, negative 10. Negative 10, not m, b. B is negative 10. 5/3 times 6 gives me negative 10. Negative 5/3 times 6. Let me show that real quick. I'll do it right here. Negative 5/3 times 6. 5 times 6 is 30. 30 divided by 3 is 10. So that's how we get negative 10. Questions on this one? This one's a little more challenging than what's on the test, but I just wanted to put it here because it's a good challenge. Any questions? No questions. Okay, so finally, here's one last question. What's the equation of the new line? What would be the equation? Good. Y equals 2x minus.
Bruh, I was being
Mm-hmm. All right. One last problem, I think. Yeah, one last problem. Here we go. Triangle ABE was dilated to create triangle ACD. Question number 1, what is the scale factor? Okay, Janelli says 4. Perla says 3. So how do we calculate scale factor? New over old. So this long segment right here, how long is this one? Careful, it's not 6. Don't be
12.
fooled. It's 12. It goes by 2s. So this is 12. It's okay, you still get the same answer. How long is this one? How long is BE?
4.
4. So old, new over old, that's 12 over 4. That's 3. Scale factor is 3. Where is the center of dilation? Negative 6 comma 4. Okay, so how did you figure that out?
Oh, they're on the same point.
Yeah, they all lead to point A. Remember, that's what the center of dilation means. So sometimes you might have two triangles that are in completely different places, right? Like we've seen that before, where you have one triangle over here and one triangle out there, and you kind of have to see like where do they all lead to? If you kind of connect them all, like where would they all lead? And that would be the center of dilation. But in this case, the center of dilation is point A. -6, 4. Questions on that? Okay. Now, suppose that ABE was dilated about point E. Suppose that ABE was dilated about point E. So it's telling us, let's say that E was the center of dilation. What transformation would be necessary to result in triangle ACD? Okay, so if this triangle is actually dilated around point E, what would happen is it would still be a scale factor of 2, but it would go this way. Or scale factor of 3, I mean. So it'd end up going this way. Does that make sense? So if that was the case, what else would you need to do in order to bring your image to where it should be? Good, translate it. So translate it, how many units and where? Some down, some to the right. How many? Four down. And 8 to the right? Yeah. Because again, it goes by twos. So just be careful. It's going by twos, not by ones. So that would be correct. So in order to bring it to where it should be, it would have to go down 4 and then 2, 4, 6, 8. Now obviously the one I drew is a little bit too big, but there we go. Okay, last question. What if the center of dilation was point B? If it was point B, where would it need to go? Down, how many units? 4. Good. 1, 2, 3, 4. So any questions on this one? Any questions on center of dilation? Okay, awesome, awesome. Well, that brings us to the end, y'all. So good job today. Good participation today. Tomorrow we'll do a review of similarity. So yesterday we reviewed right triangles. Tomorrow we review similarity. And then on Monday we'll do a more like general review. Maybe I'll throw in a Kahoot in there. We'll see. But that'll be that. So any final questions before we go? All right, guys. Good job today. Have a great day. See you tomorrow.